In this lecture, we'll talk about how Internet censors can restrict Internet communications through the filtering and manipulation of different Internet protocols. There are different forms of protocol interference that censors can implement. They can interfere with the IP or TCP protocols, which typically occurs through some form of blocking. They can manipulate or block the domain name system, the protocol that's responsible for mapping internet names to addresses. They can interfere with the internet routes, the path that traffic takes from A to B on the internet, by performing an attack called BGP hijacking. They can block or redirect requests for web pages. And they can also perform a practice known as throttling, or slowing down the performance to specific internet sites or services. Let's talk about how an internet censor can interfere with TCP/IP. First, we need a little background on what TCP/IP is and what it's responsible for in the internet. Internet endpoints have addresses that are called Internet Protocol or IP addresses. A common version of this protocol on the internet is IPv4, and so we often talk about IPv4 addresses, which have 32 bits. There are 2 to the 32 IPv4 addresses on the internet. There's also a version of the Internet Protocol called IPv6, which has 128 bits. But for the purposes of understanding internet censorship, it's sufficient to talk about IPv4. IPv4 addresses are typically represented in so-called dotted quad notation, as shown here. 4 numbers from 0 to 128 separated by periods. Each number thus represents 8 bits of a 32-bit address. Here's an example showing the IPv4 address of the site corresponding to www.cs.uchicago.edu. An Internet Protocol address, or an IPv4 address, typically has a network portion and a host portion. A computer networks course would go into more detail about the distinction between the network and host portion of the Internet Protocol address. For the purposes of understanding internet censorship, it's sufficient to know that groups of hosts on the internet are represented by the network portion of the address, which is sometimes called the prefix or an IP prefix. A prefix, or a network address of 16 bits, as shown here, represents a collection of 2 to the 16 hosts, which would be represented in the host portion of the internet address. The Transmission Control Protocol, or TCP, is responsible for reliable, in-order delivery of data on the internet. It has 2 main phases, the connection setup phase and the data transfer or exchange phase. The setup phase is called a three-way handshake, the process of which you can see here. A sender on the left who wants to communicate with another host on the right would first send a so-called SYN packet, which would be answered with another SYN, or a so-called SYN-ACK packet. The third part of the three-way handshake is the acknowledgement, or the ACK, of the second packet, the SYN-ACK. After these 3 packets are exchanged, the connection is set up and data transfer can take place. The sender sends some amount of data in a so-called window, and the receiver acknowledges windows of packets that are received in order through ACKs, or acknowledgements. At the conclusion of a data exchange over TCP, or a so-called session, the sender and receiver will tear down this connection using an exchange of FIN packets. There's also a packet called a reset packet, and that's an important packet to know about because it plays a role in internet censorship, as we'll see later on in this lecture. A common mechanism for interfering with TCP/IP is through a so-called firewall, where 2 parties, Alice and Bob, may want to communicate with one another, but some device that's on path interferes with their communication. Performing this kind of interference on a large scale requires some kind of topological choke point. So if the network is a graph and we have a bunch of hosts on one side of the firewall and a bunch of hosts on the other side, we'd like to find the cut in that graph that has high conductance. In other words, we can make a cut or place the firewall at a particular point in the network that partitions a large number of censored hosts from the uncensored part of the internet. Firewalls are often used in security applications as well, when there's a network perimeter that can be protected. For example, a campus or enterprise network might commonly deploy a firewall to protect hosts on its network from other hosts on the rest of the internet that might seek to attack hosts on the enterprise or campus. There are a lot of different software packages that implement firewalls. Several open source implementations include Snort and IP tables, and a popular commercial firewall product is called Blue Code. One way that firewalls interfere with TCP connections is to inject so-called reset packets. An on-path firewall system can detect content that should be censored and inject traffic, specifically a reset packet that resets the TCP connection, or essentially tears it down. That causes the client to abort the connection or otherwise report some kind of generic error. Those who have studied the implementation of the firewall in China have noticed that that firewall can sometimes look for specific content or communication between known endpoints as a trigger to inject these TCP reset packets. Another mechanism to interfere with the TCP connection is simply to inject a packet with a duplicate sequence number. If a host on the internet receives a packet that has the same sequence number in a stream of bytes as one that it's already seen, it may reject the second packet it sees with that same sequence number, thinking it's a duplicate of something that it's already seen. Thus, by injecting a packet with another sequence number in the stream ahead of the real traffic, a censor can cause a client to suppress or drop the legitimate traffic. In summary, TCP/IP is the protocol that most internet applications rely on for reliable internet transport. A common way to interfere with a TCP/IP connection is to simply reset it, but there are also mechanisms such as introducing duplicate sequence numbers in a byte stream that would cause a client to drop subsequent packets in the stream. A firewall can block traffic in either direction or in both directions. And blocking can be based on content after an initial packet exchange and the inspection of the stream's contents, or simply based on the communication endpoints as determined by inspection of the IP addresses in the packets in the traffic stream.